Hello and welcome to Cashmatics. This is part 6 in my series on complex numbers, and I've decided to do another tutorial on loci on the Argonne diagram because in class a number of students were struggling to understand what some of the questions were asking of them. So I've got 3 examples which I'll go through, and hopefully by the end things will be clearer and you'll be able to answer similar questions. So as always, grab yourself some paper and a pen and let's get started. Now these first 2 examples are quite straightforward, but before we start them, what I'm going to do is just remind us of what we know already. Now if you have a circle, you have z minus z1 is equal to r, and for the argument we have the argument of z minus z1 is equal to some angle theta, and z1 is the focal point. Okay, that's the point we're interested in. In the case of a circle, that's the center of a circle, and in the case of the argument is where we're measuring the argument from. So if you look at this first example, we've got the argument of z is equal to pi over 3, which means that z1, the thing we're subtracting, is actually 0. Okay, so the center for this point is there. That's where we're measuring things from. And pi over 3 is 60 degrees. Okay, so I can just draw a line like that, and that would be pi over 3. So this means z lies somewhere along this line. Okay, and that carries on forever. Now in this second example, I need to work out where I'm measuring the argument from. Okay, because I haven't just got z, I've got z take away some other complex number. So if I think of this as z take away 1 take away 3i, okay, so if I was to expand the brackets, what I'd get is minus 1 plus 3i, and that means z1 is measured from this point here. So let's just plot that. So 1 minus 3, that's down here somewhere, so 1 minus 3. And I need to measure from this line here, so this line is where your 0 radians is, and 2 pi over 3, that's 120 degrees, so that would be over here, and that angle there is 2 pi over 3. That means that number z lies somewhere along this line. Okay, so the argument is measured from this point here instead. So hopefully that's clarified what happens in those type of questions. Now this next example is a little bit trickier. The first part you should be able to handle because we did it in the last video. Okay, a very similar question anyway. And parts of the second part we've done in the last example. Alright, so we're going to put all that together to try and solve this problem. But before I start it, I need to emphasize the importance of having a decent sketch. It's really going to help you out a lot when it comes to solving a problem like this. So let's crack on. Right, so here's a circle all sketched out. Okay, so the center is at minus 6, and the radius is 4. And what I'm going to do is I'm just going to put on some information which I think might be useful. So that's going to be at minus 2, because if this here is at minus 6 and the radius is 4, that will be at minus 2, and similarly this here will be at minus 10. Okay, now we're trying to work out the maximum value and the minimum value of z, or the modulus of z. So what that means is the minimum distance from here to the circle. Now remember, the minimum distance has to go through the center of the circle. Okay, so a line going through the center of the circle. I explained why that was in the last video. So I'm just going to draw a line to the center, okay, and then through the center there. So z min will be that point, z max will be that point. Okay, so that is z max, and this here is z min. Okay, now these distances here are both 4 because that's the radius of the circle. So what I need to do is work out the distance from, sorry, not O. What I need to do is work out the distance from the center to the origin. And I can do that using Pythagoras, okay, because this is 6, OC will equal the square root of 6 squared plus 6 squared, which is root 72, which is 6 root 2. So I can easily work out what Z min is now. Okay, so Z minimum will equal the distance from the origin to the center, take away 4. So 6 root 2 take away 4. And Z max will be 6 root 2 plus 4. So from here to here, 6 root 2, then plus 4 to get to the other side of the circle. Okay, so that's the first part done, nice and straightforward. Now this second question is a little bit trickier. I've underlined the important information over here. I'm just going to write that down here. I'm going to write it slightly differently. I'm going to write it as the argument of Z takeaway and that would be 4 minus 2I equals theta. Okay, which means the important point on my diagram is 4 minus 2. And this is where having a decent diagram really helps. So 4 minus 2, 4 across and 2 down. That'll be there somewhere. And I know it's going to be in line with this point here. Alright, so here we've got 4 and here we've got minus 2. Okay, so that's going to be really important to us. And what the question is asking for is the angle at which I'd need to draw a straight line from here so it would miss the circle, so it wouldn't touch the circle. Alright, so let's just draw a line across here like that, and then draw a line over here. Okay, so remember the angle is measured from here, so in the anti-clockwise direction that angle there is pi over 2, and what I need to do is work out what this angle is over here as well. Alright, so the first bit is easy. Okay, so remember this is where I'm measuring my argument from, so as long as the argument is less than, so as long as the angle is less than pi over 2, so as long as theta is less than pi over 2, okay, so in this direction pi over 2 would hit the circle, I need it to be less than pi over 2, then I'm not going to have a solution. Okay, that's the easy one. The more difficult one is this angle over here. Alright, and in order to do that I'm just going to use some simple trigonometry. Okay, so let's start by putting some important information on this diagram. Okay, so this point here, that's at minus 6, which means the length from here to here, so I'm just going to put it in green, hopefully you can see that, this is going to be 10 units. Alright, this here is already 4 units, that's the radius, and I'm going to draw a line from here to here, and what I'm going to do is I'm going to work out this angle here. Right, now that angle there, and if I put some more information on there, is going to be the same as this angle here. Alright, because that's the radius and that's the radius. These two lengths are the same and these two lengths are the same, which means I've got two similar triangles, so these angles in the middle are the same. So what I need to do is work out what this angle is first. Alright, so that there is going to be the inverse tan of, now just have a look at this triangle, it's the opposite over the adjacent, so 4/10. Okay, not 4/16, sorry, 4/10. So from here to here is minus pi radians. So what I need to do is minus pi radians plus 2 of these angles here. Okay, so it'll be minus pi plus 2 times the inverse tan of 2/5. Okay, remember 4/10 is 2/5. Okay, so minus pi plus 2 times the inverse tan of 2/5, and that gives me theta equals 2.38 radians. Okay, so my final answer is, for it to not have a solution, theta needs to be less than pi over 2, and theta needs to be greater than minus 2.38 radians. Minus 2.38 radians. So my final answer, for these not to have a common solution, theta needs to be less than pi over 2 and theta needs to be greater than minus 2.38 radians. Okay, and I can write those as a single inequality, so theta will be less than pi over 2 but greater than minus 2.38 radians. Right, and this final question looks quite tricky, but what we'll do is we'll just take it in small, easy to manage steps and we'll go through the solution. Right, the first part, let's see what it means. Okay, the complex number z is represented by the point P on the Argonne diagram with this equation. Sketch the locus of P. So basically what that part means is P is on this circle somewhere, so we just need to sketch that circle. And we need to get the important information out, so we need the centre of the circle, which you should be able to work out is minus 8, 4, and it's got a radius of 2. Now I should have found that bit straightforward. Okay, that was quite easy to do. Now I'm just going to put some additional information on here. Okay, so I'm just going to put a line across from here, because I know that coordinate is 2, and over here, okay, that's the y coordinate of 6. Okay, and that's going to help me with the second part. So it says, show that the maximum value of the argument of z plus 15 minus 2i is 2 times the inverse sine of 2 over root 53. So from here, I can extract the important coordinate, which would be minus 15, 2. Okay, so let's just plot that. Minus 15, that's down here. 2, and that's going to be in line with this. And what the question is asking me is, what is the maximum angle I can make from this point here to that circle so it still touches the circle? So I need to draw a tangent to that circle first, which is that, and I need to work out this angle. Right, so how am I going to do that? Again, we're just going to use some trigonometry to do it. So I'm just going to mark on a triangle for you. And what I'm going to do is use this triangle that I've marked here in green to work out the length from this point here to the center of the circle. Okay, now this length here on the bottom of the triangle is 7, and this is 2, okay, which makes this length the square root of 7 squared plus 2 squared, which is the square root of 53, which I can see over here. There's a square root of 53 over here. Right, so I'm just going to mark an angle theta, so that angle there. Now remember, that is half the angle I need, because these two triangles, if I mark this one on, okay, so the triangle up here is identical to the triangle down here. Right, so theta would be the inverse sine of the opposite, which is 2, divided by the hypotenuse, which is root 53. So the angle I need is 2 times the inverse sine of 2 over root 53. Okay, so that's the maximum argument. That's the maximum argument that I'm looking for. And that's part B done. Right, and finally part C. Okay, let's have a look what it says. Find the exact values of the complex numbers that satisfy this circle, and this will just be a straight line. Okay, now the important point here is 0 minus 4. Hopefully you know how to extract that now. Let's just mark that on here. So that'd be down here. And it's got an argument of 3 pi over 4. So 3 pi over 4 is over in this direction. Alright. Now what that means is that angle there is 3 pi over 4. Now 3 pi over 4 is actually quite nice. If you think about it, that's 135 degrees. So this here would be 45 degrees, which means it's actually got a gradient of minus 1. So the equation of this line is going to be y equals minus x plus, now let's see if you can figure this out. We know the coordinates of this point are 0, minus 4. Okay, so when y is equal to minus 4, x equals 0. So if x is 0, this has to be a minus 4 here. Okay, so add minus 4. So y is equal to minus x minus 4. Now what makes this line easy to use for us is because this coordinate over here is minus 8, 4. Okay, so minus 8, 4. So when x equals minus 8, okay, so minus 8 would be 8. 8 take away 4 is 4, which means this point here actually lies on this straight line. And that actually makes it quite handy. Okay, now you might be tempted to solve the equation of this line with the circle, but there's actually a much easier way to do it. And what I'm going to do is I'm just going to mark on 2 points, so that point there and that point there. And if I was to mark on a triangle there and a triangle there, and let's just mark this with a B and call that a B, okay, because it's 45 degrees, that makes that length the same as that length. Okay, so it's really handy. And sorry, not B, sorry, not C. Now at this point here, you might try and solve the equation of this line with the equation of this circle. Okay, but you're going to end up making a lot more work for yourself than you need to. But like I said, this angle here, this 45 degrees, makes things a lot easier. Okay, because that means that this length here and this length here are exactly the same. So if I call that B and call that B, what I can do is I can work out the length of B, which will help me to work out the coordinates of these points, because if I can work out B, the x coordinates will be minus 8 plus B and minus 8 take away B, and the y coordinates will be 4 take away B and 4 plus B. Alright, so let's just work out what this is. So I've got an isosceles triangle here, so this is what I've got. Okay, radius of 2, that is B and that is B. And let's just do some simple Pythagoras. So b squared plus b squared is equal to 2 squared. So 2b squared is equal to 4. B squared is equal to 2. So b is equal to root 2. I'm not bothered about the plus and minus just yet. I'll know when I need to add them, when I need to subtract them. Okay, so let's have a look. So I'm going to go for this coordinate first. So I need to add b onto minus 8 and take away b of the 4. So the coordinates of that point are going to be minus 8 plus root 2 and 4 take away root 2. And for the other coordinate, minus 8 take away b for the x coordinate and 4 plus b for the y coordinate. So minus 8 take away root 2 and 4 plus root 2. Okay, so that's given us a little shortcut to actually finding out those points. Right, so hopefully you understand what some of these questions mean now. Okay, they do take a bit of practice, but once you get used to doing the questions, you will understand what they mean, hopefully. And that's all there is for now. In the next video, what I'll be doing is showing you how to identify regions on the Argonne diagram, which is actually quite straightforward. And that'll be the end of complex numbers for the year 1 part of the syllabus, and then we'll do the year 2 part of the syllabus as well. But that's all for now, and I'll see you next time. Goodbye for now.